Hi dear, today we'll see the revision from the NCERT exemplar questions. Okay, whatever portion for the test, we'll complete that question alone. Okay, which of the following can make a parallel beam of light when a light from a point source is incident on it? Okay, so actually this covers the lens also. They covered the lens portion also, but from what we studied, which mirror, two types of mirror we have studied, concave and convex, right? Which mirror is used to get a parallel beam of light? Here we have learned the uses of mirrors, right? So parallel beam of light, which mirror will give? Concave mirror, right? Concave mirror. Once we study the convex lens, you will come to know that convex lens also will give the parallel beam of light when a point source is incident on it. Okay. So to get a parallel beam of light, we use the concave mirror. Okay. Next, question number 3. Under which of the following condition a concave mirror can form an image larger than the actual image? In which condition the concave mirror? In case in the do you remember that when it will make a larger image, which condition concave mirror can form an image larger than the actual image? We have seen that, right? When it is between C and F, when the object is placed between C and F, you will get a larger image. You remember that beyond the C you will get a larger image. Okay, so when object is placed between focus and the center of curvatures, between C and F, you will get a enlarged image. Okay. Next, okay, magnification produced by a rear view mirror fitted in a vehicle. So what mirror is fitted in the vehicle? You will learn that convex mirror, right? Convex mirror. Okay. So magnification means what will be the size of the image when compared to the original image, right? So what is the purpose of using the convex mirror? It has a larger field of view. So when it covers a larger field of view, the images will be small in size, right? So when compared to the object size, this image size will be very small. Okay. When the numerator is small and then denominator is bigger, means definitely you will get a what value is 0 point something only, right? It starts from 0 point something. So this magnification produced by a rear view mirror fitted in the vehicle is less than 1. For example, you can take this. For example, the size of the height of the object is 2 meters. And the image formed is 1 meter, means what? 1 by 2 means what? 0.5. So it is less than 1. Okay. Next one. Rays from sun converges at a point 15 centimeter in front of a concave mirror. Where should an object be placed so that the size of this image is equal to the size of the object? What they said. So they kept a concave mirror. So when will you rays from sun means from infinity, right? From infinity it is passing through. So when it is parallel to the principal axis, then it will converge at the point of focus. Am I right? So at the point of focus it will converge. It is 15 centimeter from this. Okay. For this mirror, the point of focus is here, right? Focal point is here. You know that when the object is placed at the C, center of curvature, then only you will get the, whatever the size of the object is placed, you will get the same size image in the same place, right? So, object should be placed, your focal length is 15 centimeter, means center of curvature is double the time, right? C will be here, it is 30 centimeter, correct? For this mirror, center of curvature lies in the 30 centimeter in front of the mirror, right? So that is 30 centimeter in front of the mirror. Okay. Next, a full length image of a distant tall building can definitely be seen by using what mirror? So when it is a tall building means definitely we need a wider field of view, should be wider. Okay. So in that case we will go for the convex mirror. Convex mirror has a wider field of view, right? Next, the laws of reflection hold good for even for the plane mirror, for the concave mirror, for the convex mirror, whatever the mirror may be, all the mirrors irrespective of their shape will hold suit for laws of reflection. What is that laws of reflection? Angle of incidence equals to angle of reflection. Whatever the mirror may be, plane or concave or convex, it holds all the laws of reflection. That is two laws. Okay. The normal, the incident and the reflected ray all lie in the same plane, and the angle of incidence is equals to angle of reflection. Okay. So this law of reflection holds good for all the mirror irrespective of their shapes. Next, which of the following ray diagram is correct for the ray of light incident on a concave mirror as shown in the figure? This is one of the diagram. If the light is incident like this, where it will be, where is the reflected ray will pass through, right? So this is from infinity. This is parallel to the principal axis. When it is parallel to the principal axis, definitely the reflected ray will pass through the focus only. Okay. Here in the first diagram, it is between P and F. So this is wrong. This is 2F at the center of curvature. This is also wrong. Here in the third case, it is reflected back in the same way. So this is also wrong. So in the fourth figure, this is passing through the focal point. So this is your correct answer, figure D. Okay. Next. Okay. A child is standing in front of a magic mirror. She finds the image of her head bigger. Okay. Her head is bigger and middle portion of her body of the same size and that of the legs smaller. The following is the order of the combination for the magic mirror from the top. So what is this? Head is bigger and the body is of same size and the legs is very small. Okay. So what are the combinations of the mirror from top to bottom? Okay. So when the child is standing in front of the mirror means definitely it will be between the pole and the focal point. Correct? The child will be standing in between the pole and the focal point. When will you get this larger image when the object is placed between pole and the focal point means when you place a concave mirror. In the concave mirror, when the object is placed between P and F, you will get a enlarged virtual image. Right? Do you remember this? So her face is bigger when you keep a concave mirror here. So in the middle part, only the plane mirror will give the, what is that, same size, right? When we stand in front of the plane mirror, it will give this, what is the size of the image? It will give object, it will produce the same size of the image, okay, as that of the object. Next, in the last part, which mirror will give, when the object is placed between pole and the focus, which mirror will give the diminished image, diminished virtual image, that convex mirror, right? So you will get a diminished image which is you will get like this, right? You will get between the pole and focus, you will get a diminished image. Okay, this is your convex mirror. Okay, so the combination of the mirrors are concave, plane and then convex. So bigger image, same size and smaller image. Okay, In which of the following the image of an object placed at infinity will be highly diminished and point sized? In which of the following the image of an object placed at infinity? Whatever the whatever the mirror may be. If it is a concave mirror, when it is placed at infinity, you will get a highly diminished image. Okay. And also in the case of convex also, when the light is light rays coming from the infinity, you will get a point size, diminished size image. Okay. So in both concave mirror as well as convex mirror, you will get a highly diminished point sized image. Okay. So this is out of fashion as of now for us. Okay. This convex lens and concave lens. Okay. So we need to go for that. Okay. Next, identify the short answer question. Identify the device used as a spherical mirror or lens in the following cases when the image formed is virtual and erect in each case. Virtual and erect. Okay. The object is placed between device and its focus. The image formed is enlarged and behind it. Right. What is this case? The object is placed between device and its focus. See, when the object is placed between device and its focus, you will get a virtual image enlarged behind the mirror. So this is your concave mirror. Okay. Concave mirror. So this is your concave. What I identify the device they are telling, no, this device is your concave mirror. Okay. Next, object is placed between the focus and the device. The image formed is enlarged and on the same side on the object. Actually, there is a not focus, between the C and F. That is between C and F. Actually, this is C and F. Okay. You will get the enlarged and the same side as that of the object, means this is also concave, right? You will get a enlarged image when it is placed between C and F. Okay. Next, the object is placed between infinity and the device. The image formed is, this you have to change it, not between focus and center of curvature. Okay. The object is placed between infinity and the device. Now image formed is diminished and between focus and optical center as the same side as that of the object. This is also what? This is your concave mirror. Okay. Next, object is placed between infinity and the device. Image formed is diminished and between pole and focus. Behind it na, when the object is placed between infinity and the device, the image is formed behind the mirror, means then it is a convex mirror. Okay. So your image will be behind the mirror. So this is your convex. Next, that's all. Next one is okay. Under what condition in an arrangement of two plane mirrors, the incident ray and the reflected ray will always be parallel to each other, whatever may be the angle of incidence? Show the same with the help of diagram. Okay. At what condition in an arrangement of two plane mirrors? So two plane mirrors are placed in such a way that the incident ray and the reflected ray will always be parallel to each other. Okay. Whatever the angle of incident ray may. So at what condition means when a plane mirrors are kept at a 90 degree. When it is placed as 90 degree, for example, this is your incident ray, this is your normal. So the reflected ray will be like this, right? So this is your reflected ray. Again, this is your mirror, plane mirror, this is your normal and this is your reflected ray. I'm just approximately drawing all this thing. Even then you can see this is the incident ray and this is your reflected ray. It looks like parallel, right? Okay, you will actually, you are having the proof to show that these two lines are parallel to each other. If you try to prove that the corresponding angles are equal, then these lines must be parallel to each other. You have learned in the maths, right? When two lines are parallel, the line passes through, the transversal line passes through that. If you try to prove that these two angles are equal, then these lines are parallel to each other. So we can prove like that. Okay. So this is under what condition in an arrangement of two plane means the plane mirror should be placed at right angles to each other. Okay. Next, draw ray diagram showing the image formation by a concave mirror when object is placed. They are given all the five conditions. We learned all the 6 conditions, right? Do you remember that? So you are supposed to draw that, and also for this draw ray diagram showing the image formation by the convex mirror when the object is placed at only 2 positions, at infinity and the infinite distance from the mirror. Do you remember that? This for the concave mirror, when the object is at infinity, you will get the image at the focus point, right? You can get the image at the focus point, right? When it is beyond C, when the object is placed beyond C, you will get the image between C and F. When the object at C, you will get the image at C itself. When the object is between C and F, you will get the image beyond C, enlarged image. Next, when the object is at focus point, you will get the image at infinity, right? When it is between P and F, you will get a enlarged image behind the mirror. Okay, this is for concave mirror, and for convex mirror only 2 positions. When it is placed at infinity, you will get a point sized image at the focus point. When it is placed between the pole and the infinity, somewhere finite distance from that, you will get the image between pole and the focus. It is small sized image. Okay, clear on this? Thank you.